Now Carlos needs to deploy migrations to a shared environment in Azure. There are many ways to accomplish this. Carlos prefers to build the migration bundle into a Docker image. Then he will deploy that image to an Azure Container Registry. And finally, he will create an Azure Container instance to run that image and upgrade the database. He begins with a Docker file very similar to the one that he created for persistence testing. This script restores and builds the API project and its dependencies, but there's no need to run the tests. Those were already run in an earlier build step. Instead, he jumps straight to building the migration bundle. This time, however, he adds the self-contained flag. That produces an executable that can be run without using the .NET SDK. The self-contained executable will be bigger, but because it requires fewer dependencies, the final Docker image will be smaller. You see, Carlos is going to be using a multi-stage Docker file. The first stage is the build image, which is based on the .NET SDK. And the second stage is the runtime image, which is based on the .NET runtime. He copies the bundle from the build image into the runtime image. And then he copies the app settings JSON and the run script from the original source. The run script simply executes the migration bundle and gives it the connection string. He has to set a default value for the connection string environment variable so that he can override it with the proper value when he creates the container. And then he executes the run script. Now he builds the image. He uses as a prefix the name of the Azure Container Registry to which he's going to deploy the image. The Docker file compiles the source code, creates the migration bundle, and then copies that to the runtime image along with the app settings JSON and run migrations.sh. He wants to run a quick test of this image, and so he logs in to the Azure Container Registry. And then he pushes the image up to that registry. And now an Azure Container instance can pull that image from the registry and run it. Carlos will need to give the container instance access to the registry, so he shows the ACR credentials that he will need to enter. And then, when he creates the container instance, he specifies the environment variable for the admin connection string. Here, he provides his ACR credentials so that the container instance can pull from the registry. Once the container instance is created, he attaches to standard out so that he can watch its progress. It connects to the database and attempts to run migrations. In this case, the database is already up to date. So far so good. He's able to connect to the database because the migration bundle is running inside of Azure, behind the firewall. He doesn't need to create a new firewall rule. Now he can go ahead and delete that container instance. He'll perform these steps inside of the build and release pipelines so that he can create a new container instance every time he deploys the application. Carlos is going to set up Azure DevOps to build and release database migrations. His first step is to set up a build pipeline that creates the migration bundle as a Docker image. This build will push the image to the Azure Container Registry. And that will set him up for the next step, which is to create a release pipeline to deploy the migrations to the target environment. If you'd like to follow along, all of the code is in the resources attached to this course. The tasks used in the build pipeline are part of the Azure Pipelines.yaml file. In Azure DevOps, the release pipeline is typically not committed to source control, and so I've instead documented those steps in the README. Now let's follow along with Carlos. He begins with the build pipeline. He's using a Linux build agent, and so far it installs the .NET 6 SDK and runs the build for all projects. Then it runs the unit tests and publishes the API project. The final step produces build artifacts from the staging directory. And now he wants to build the migration bundle. He uses the Docker task. He has previously set up a service connection to the Azure Container Registry, and so he selects it here. Then he enters the name of the container repository, which is the same as the name of the image without the tag. He's going to build using the migrations Docker file and the build context of the default working directory. Now, instead of the build ID, he uses the build number as the image tag. This will make it easy to correlate in the future. And now he has a task that will build and push his migrations Docker image. Now, when he saves the build script, it triggers a new build. It builds the Docker image and then pushes it to the Azure Container Registry. When Carlos looks at that Azure Container Registry, he sees that the repository now contains an image with the build number as the tag. And so now he can use it in a release pipeline. He adds an Azure CLI task so that he can create the container instance. He has already set up a service connection to his Azure subscription, so he selects that here. He'll use the script type PowerShell core so that this can run on the Linux build agent. And he opts to create an inline script. In this script, he creates the container image, much like he did from his developer workstation. But this time, he uses a variable to specify the admin connection string. He also uses the build number as the image tag so that he deploys the correct version of migrations. And finally, he specifies the registry username and password. He uses pipeline variables in order to protect those secrets. He sets the GlobalTicket admin connection string and then clicks the lock so that he protects the secret. He also does the same for the registry password. And then back in the script, the next thing that he does is to attach standard out to the migration container. This not only copies the output into the release logs, but it also waits for the migrations to complete. And then, once it's complete, he deletes the container. He saves and runs the release pipeline. It deploys the app service, as it did before, but then it deploys the migrations. It does so by creating a container instance, which runs the migration bundle. It runs the migrations that are consistent with the code that was just deployed. It's able to connect to the database from behind the Azure firewall, using database credentials that are not available to the application. Carlos has found that migration bundles are the best way to build and package EF migrations. They are standalone executables that can deliver schema updates without the .NET SDK or your source code. His preferred way of delivering migration bundles is through Docker images. When running persistence tests, he applies the migration bundle in the test container using Docker Compose. And while deploying to shared environments, he uploads the image to a container registry for secure deployment behind the firewall. This combination gives him the greatest control and security. Hello, and welcome back to EF Core 6 Best Practices. I'm Michael L. Perry. C# 8 introduced nullable reference types, and EF Core 6 takes full advantage of that feature. Together, they help you build safer code by controlling nullability. Turing Award winner Tony Hoare calls the invention of the null reference his billion-dollar mistake. After all of his contributions to the field, I think he can be forgiven. He introduced null references to the ALGOL programming language in 1965. And given how useful it is to represent uninitialized values, surely someone was bound to come up with this solution. There are other options, but there are none as simple and general, and yes, as dangerous, as the null reference. Languages have evolved different strategies for handling null references. Low-level languages, like C and assembly, run on the bare metal. They don't have a runtime to check for the use of a null pointer. In these languages, dereferencing a null pointer typically crashes the entire program. Managed languages, like C# and Java, have runtimes, and that runtime will check every reference as it's used. If the reference is null, then the runtime throws an exception, which terminates the call stack but recovers the program. Null-safe languages, like Dart, Rust, and Swift, use the type system to verify at compile time that a null pointer is not dereferenced. and C# added support for compile time null checking in version 8. EF Core builds upon those features, so let's see how they work. Nullable reference types were introduced in C# 8, and before that, all reference types allowed null. But now, with this feature turned on, a reference type must be explicitly declared as nullable. By default, a reference type would be non-nullable. To enable null reference types in your project, add the Nullable Enable setting to the property group section of your CS_proj file. If you create a new project with .NET 6, this option will be set for you. With this option turned on, the compiler will warn you whenever a variable without a question mark is not initialized. For example, in the venue entity, the compiler warns us that the non-nullable property name must contain a non-null value when exiting the constructor. The constructor in this case is the parameterless constructor that's created for us by default. Now, be very deliberate in how you resolve this warning. EF Core uses nullability in order to determine the column type. And so, if a column should allow nulls, then make the property nullable. But if the column should be required, then give the property a reasonable default. This warning also affects DB sets inside of our DB context. The GloboTicket constructor does not initialize the DB sets because we know that Entity Framework will do that for us. But the compiler has no idea, so it warns us about the non-nullable property venue. Carlos wants to take full advantage of compile time null checks, and so he works through all of the warnings. Once he's eliminated all of them, then he will elevate those warnings to errors so that nullability issues don't creep back in. Carlos is ready to take care of some of those compiler warnings. First, he'll focus on the nullable and non-nullable columns. He'll map nullable properties to optional columns, and then he'll initialize non-nullable properties for required columns. Carlos currently has 8 warnings, and 2 of them are related to the venue entity. Both the name and address properties are non-nullable, but yet not initialized. The warning recommends that he consider declaring them as nullable, and that makes sense for the address. Carlos wants the address of a venue to be optional. So when he declares address to be an optional property, one of the warnings goes away. But that's not the only effect of making that property nullable. When he creates a new migration to make the venue address optional, Entity Framework recognizes that it needs to alter the column. When nullable reference types are enabled for a project, Entity Framework will use that type information to determine whether a column should be nullable. That means that the isRequired Fluent configuration is now redundant. He doesn't actually need to declare that the name is required because Entity Framework will determine that based on the data type. To prove that to himself, he generates a new migration after changing that configuration and notices that it makes no changes. Perfect. So now he can remove that empty migration and focus on taking care of the compiler warning around the name. Entity Framework is doing the right things with the name and address properties, but he still has the warning that the name is not initialized. To fix that, he simply initializes the name property to an empty string. This takes care of data columns within entities, but we still have a problem with navigation properties. The show entity has 2 navigation properties, venue and act, that are both non-nullable. There's a quick and dirty way to get rid of this warning, and that's to use the null forgiving operator to initialize these properties. That's the exclamation point after an expression, in this case, null. The null forgiving operator tells the compiler to ignore the fact that this expression could be null. In this case, it's kind of like the warning label on a package of peanuts that this product may contain peanuts. But this is incorrect. It actually initializes these properties to null even though we've declared them to be non-nullable. This would allow incorrect code to compile, leading to runtime errors, and Carlos wants to avoid that. And so instead, Carlos will go for a different solution.